was reflection?
Reflection, my friends, is defined as the return of a sound wave, or an echo.
The fraction of energy reflected by a surface depends on the structure of that particular surface. To elaborate, much energy is reflected off of a surface that's rigid and smooth, and less energy is reflected from a surface that's more, soft and irregular. Right, bro?
So when a wave is going to undergo reflection, it's going to reach a boundary between one medium and another. Now, dependent upon the dissimilarity of those mediums is going to dictate how much of the sound wave is reflected. So in our given example, we had me, myself, Elijah, yelling in the gym. Now, the first medium that the sound wave will travel through is the medium of air. But because the medium of air is very dissimilar to the medium of the concrete walls found in the gym, there's going to be more reflection rather than transmission of the sound waves. And due to this greater reflection than transmission, you're going to have more sound waves echoing or returning to the ear for you to hear them.
Contrary-wise, in our following example, which I'll show in just a minute, we tried projecting in a classroom, and actually in Rossler, but we noticed that there was a lot less reflection, there was a lot less echoing in the classroom, and we concluded that this was because the classroom had carpeting on the ground, and this carpeting was relatively soft. So because the carpet was relatively soft, the carpet was more similar to the medium of the air, more of the sound waves were transmitted or absorbed by the carpet rather than reflected. That's why we could hear less of the sound waves, and that's why there was less echoing.
Swag.
And guess what? Similar to light, the angle of incidence in which the sound wave reaches the surface that's reflecting it is actually equal to the angle of reflection. Now, I think that's enough light for today.
Reverberation, my friends, is sound due to multiple reflections.
Swag!
Reverberation. So, in our given example, you saw me screaming in the locker room. Now, why is this example different from the example in the gym? Why does it reverberate rather than echo? So in the gym, as you saw, we still had multiple surfaces. We had the right wall, the left wall, the ceiling. But in the locker room, we're going to have many more surfaces. There's going to be walls within the bathroom, within the shower, but we're also going to have the lockers. Now, because of this, the sound waves that are transmitted from my mouth are going to be reflected from many surfaces. Now, because it's reflected from many surfaces, the sound waves are going to travel back to me from all directions. And because of this, you're going to be getting reflections at many different times, as you're going to have some surfaces that are farther than others. Now, and because you have reflections of sound waves coming from many different directions, and you're also going to have reflection of sound waves coming sooner than others, this is going to make the sound indecipherable. So it's going to sound muffled rather than as a clear echo. And hence, we're going to get reverberation.
The hounds will stay in chains.
Okay, on to refraction. So, refraction is basically the bending of sound waves as sound waves change speed caused by sound waves traveling from one medium to another, or just traveling through a non-uniform medium.
So in this given example, we're going to have a non-uniform medium. So it's all going to be air. But the warmer air is going to have more collisions, so the molecules are going to be faster. Contrary-wise, the cooler air is going to have less collisions, so the molecules will move slower. So as the sound waves travel through the warm air, they're going to move fast. But once they come in contact with the molecules of the cooler air, it's going to cause the wave to refract or bend as it slows down, which is going to cause it to move upward.
In this case, however, which normally actually happens at night as illustrated above, the sound immediately hits the cooler air. And this cooler air, as EJ said, doesn't have as many collisions and thus allows the longitudinal waves to travel slower. Thus, because the sound waves are slowed down, they bend downward.
In summary,
reflection, the bouncing.
Reverberation, many bounces.
Refraction, the bending.
Now, my friends, you've learned about sound. And guess what? We're on each other's team.